Good morning to all. Today we shall discuss about the Raabe's test. Raabe's test. This is also important for you must. Important theorem statement. Let summation of un be a series of positive terms, and limit n tends to infinity, un divided by un plus 1 minus 1 into n equal to L. This is the condition. Limit n tends to infinity, un divided by un plus 1 minus 1 whole raised to n equal to L. Finite quantity, finite and unique quantity. Then first condition, summation of un is convergent. Summation of un is convergent if L is greater than 1. If given quantity L, find out madidante L is greater than 1. Summation of un is convergent. Next condition, summation of un is divergent. Condition if L is less than 1. L is less than 1. This is the statement of Raabe's test. Summation of un be a series of positive terms and condition limit n tends to infinity, un divided by un plus 1 minus 1 whole raised to n equal to finite and unique quantity L. Then summation of un is convergent, L is greater than 1. Un is divergent, L is less than 1. This is the statement of the theorem. Next, proof. Summation of 1 divided by n raised to p is convergent. This is the p series is convergent. P is greater than 1. P series P is greater than 1. Summation of 1 divided by n raised to p is convergent. And divergent if p is less than or equal to 1. P is less than or equal to 1. Now we shall compare summation of un with p series. Summation of un is equal to summation of divided by n raised to p is a p series. Let summation of pn is equal to summation of 1 divided by n raised to p. Take Pn is also summation of 1 by n raised to p. Next, summation of un is convergent. Summation of un is convergent. We applying the comparison test 3 by comparison test 3 by comparison test 3. If un plus 1 divided by un is less than Vn plus 1 divided by Vn for all n. Taking this condition, next un plus 1 divided by un is less than un means you know un is equal to 1 by n. Un plus 1 equal to un plus 1 equal to 1 divided by n raised to n plus 1 raised to p. Un is n raised to p. Taking n is equal to n plus 1 is less than or equal to 1 divided by n plus 1 raised to p divided by un is 1 by n raised to p. This is also less than or equal to, taking the numerator n raised to p divided by n plus 1 raised to p is equal to n divided by n plus 1 raised to p. Taking common. Next, if taking the reverse process and un divided by un plus 1 is greater than reverse n plus 1 divided by n raised to p. Okay, this is also written as n, taking the n outside, 1 divided 1 plus 1 by n divided by n raised to p. These are cancelled. This is next. This is also written like this: un divided by un plus 1 is greater than upon this term a plus b raised to n. Upon formula a plus b raised to n or ax plus b raised to n formula. Next, 1 plus p divided by n plus p into p minus 1 divided by 2 factorial p minus 1 divided by 2 factorial 1 by n square plus p minus 1 p minus 2 divided by 3 factorial n raised to 1 divided by n raised to 3 plus so on. This is the expansion of a plus b raised to n. Next, take both sides minus 1. Taking minus 1 both sides, un divided by un plus 1 minus 1 is greater than p by n minus 1 plus 1 cancels. This one is cancelling. Plus p minus 1 divided by 2 factorial 1 divided by n square plus p minus 1 p minus 2 divided by 3 factorial 1 divided by n raised to 3 plus conjugate. Next, un divided by un plus 1 minus 1 into n, multiplying the n is equal to, throw both sides multiplying n, it is p, because multiplying n cancel. Okay, next term p minus 1 divided by 2 factorial 1 by n square and multiplying 1n equal to 1 divided by n and so on and so on. Next, if applying limit, if limit n tends to infinity, un divided by un plus 1 minus 1 into n is greater than or equal greater than p, because applying the limit 1 by n tends to infinity is 0, total terms are 0, taking only first term p, so all terms are cancelled. Next, this is the greater than p. Next, p is also greater than 1. Next, we shall take if L is greater than or equal to p, but p is also greater than 1. If L is greater than or equal to p, p is also greater than 1, but p itself p is also greater than 1. Therefore, summation of un is convergent. Therefore, summation of un is convergent. If L is greater than 1. L is greater than 1. This is the first condition of the theorem. Next condition, case 2, when L is less than 1, when L is less than 1, this is case number 2. Next, let P be a number, let P be a number, L is less than P is less than 1. Here L is less than P is less than 1. Then the series summation of 1 divided by n raised to p is divergent. Summation of 1 divided by n raised to p is divergent. This implies summation of un is also divergent, because summation of un is equal to summation of 1 by n raised to p. 1 by n raised to p is divergent, summation of un is also divergent. Next, if un plus 1 divided by un is greater than Pn plus 1 divided by Pn for all n. In this condition, take un plus 1 divided by n is greater than Pn plus 1 divided by Pn. Next, if take the condition un plus 1 divided by un is greater than un plus 1 means n divided by n plus 1 raised to p. Okay, total term is like that. Next, reverse this statement. If un divided by un plus 1 is less than n plus 1 divided by n raised to p. Next, if un divided by un plus 1 is less than, also taking 1 plus 1 by n raised to p. Same, n outside cancels. Expand this term by using a plus b raised to n formula. Un divided by un plus 1 is less than 1 plus p divided by n plus p into p minus 1 divided by 2 factorial 1 divided by n square plus 1. Expanding the terms. Next, same, taking both sides minus 1. Both sides take minus 1. un divided by un plus 1 minus 1 is less than, taking here also minus 1 plus 1 cancels. First term p by n plus p minus 1 divided by 2 factorial 1 divided by n square plus 1. Okay. Next, taking both sides multiplying n. un divided by un plus 1 minus 1 into n is less than, applying the multiplying n term, n cancels. First term is p plus p minus 1 divided by 2 factorial. They are multiplying n 1 divided by n. Okay. Next condition, applying limit both sides. Limit n tends to infinity un divided by un plus 1 minus 1 into n is less than p. These terms are cancelled, are 0. N tends to infinity, 1 by infinity is 0, 0 into n term is 0. Okay. Next, we take the P series condition. If L is less than or equal to P, if L is less than or equal to P, but P itself less than 1, but P itself less than 1, P itself is also less than 1. But L is less than or equal to P is also less than 1. Therefore, summation of un is divergent. Summation of un is divergent. Summation of un is divergent if L is less than 1. This is the second condition of the theorem. This theorem or this Formula is using fan. ಈ ಫಾರ್ಮುಲಾ ಯಾವಾಗ ಯೂಸ್ ಆಗ್ತದ ಅನ್ನೋದಕ್ಕೆ ನೋಟ್ ಅಂದ್ಕೊಟ್ಟಾರ. ನೋಟ್ ನಂಬರ್ 1, Raabe's test is normally used. Raabe's test is normally used when D'Alembert's ratio test fails. ನೋಡ್ರಿ, ಯಾವಾಗ D'Alembert's ratio test fail ಆಗ್ತದ ಅವಾಗ ಇದನ್ನ ಯೂಸ್ ಮಾಡ್ತಾವೆ. ಯಾವಂದ್ರೆ L = 1 ಇದ್ದಾಗ D'Alembert's ratio test ಫೇಲ್ ಆಗ್ತದೆ. ಫೇಲ್ ಆದ ಕಂಡೀಷನ್ ಮತ್ತೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, Raabe's ಟೆಸ್ಟ್ ಅಂತ ಟೆಸ್ಟ್ಗೆ ಅಂತ ಎಕ್ಸಾಂಪಲ್ಗೆ Raabe's ಟೆಸ್ಟ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿ. ದಿಸ್ ಇಸ್ ದಿ ನೋಟ್ ನಂಬರ್ 1. ನೆಕ್ಸ್ಟ್ Raabe's test applying the condition if Raabe's test condition limit n tends to infinity, applying the condition un divided by un plus 1 minus 1 into n equal to 1 equal to L equal to 1 equal to L is equal to 1. The Raabe's test fails. The test fails. ನೋಡ್ರಿ, ಇಲ್ಲಿ ಏನದ, ಇದು ಈಕ್ವಲ್ ಟು 1 ಈ ಕಂಡೀಷನ್ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಈಕ್ವಲ್ ಟು 1 ಬಂತಂದ್ರೆ Raabe's ಟೆಸ್ಟ್ ಅನ್ನು ಫೇಲ್ ಆಗ್ತದ. ಫೇಲ್ ಆತಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಟೆಸ್ಟ್ ಒಂದದ ಅದನ್ನು ಅಪ್ಲೈ ನೋಡ್ರಿ. ಮೊದಲು D'Alembert's ratio ಟೆಸ್ಟ್ಗೆ ಅದ್ರ ಕಂಡೀಷನ್ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಈಕ್ವಲ್ ಟು 1 ಬಂತಂದ್ರೆ ಆ ಕಂಡೀಷನ್ ಫೇಲ್ ಆಗ್ತದ. ಅವಾಗ ನಾವು Raabe's ಟೆಸ್ಟ್ ಕಂಡೀಷನ್ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಈ ಕಂಡೀಷನ್ ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಎರಡು ಕಂಡೀಷನ್ ಬರ್ತಾವ, ಗ್ರೇಟರ್ ದೆನ್ L ಲೆಸ್ ದೆನ್ L. 1 ಲೆಸ್ ದೆನ್ 1 ಬಂತಂದ್ರೆ ಏನು ಹೇಳ್ತೀವಿ ನಾವು, L is less than 1 ಅಂದ್ರೆ ಡೈವರ್ಜೆಂಟ್, L is greater than 1 ಕಾನ್ವರ್ಜೆಂಟ್. L equal to 1 ಪಾಸಿಬಲ್ ಕೇಸ್ ಅದ. ಇಲ್ಲಿ L is equal to 1, Raabe's test is fails. Next apply the second test. Okay, thank you.